This is an annuity example. We call this retirement annuity, and this is a great example just to illustrate how useful annuities can be in the context of finance. So in our example, Jill Moran will retire at the end of 12 years. Her company retirement plan entitles her to receive $42,000 for exactly 20 years following her retirement. So she will be retiring, and then she will be able to withdraw $42,000 for a 20-year period following her retirement. So if you assume that her retirement time is 0, she will receive $42,000 annuities or equal cash flows over the 20-year period. Her company will fund her retirement plan in the 12 years to retirement through equal annual contributions into an account that will earn 9% interest. So her company will deposit certain amounts of funds over a 12-year period, which is going to earn 9% interest over this 12-year period. Once the 20-year distribution period starts, the company will move the fund to an account earning guaranteed 12% per year. So during the accumulation period, as she puts a certain amount of money, or the company on behalf of her puts a certain amount of money, that invested amount is going to earn 9% interest. Then her retirement period will start. As she withdraws money, the balance that remains in the account is going to continue to earn 12% interest per year. At the end of 20-year distribution period, the account balance will be drawn down to 0. Now, you need to pay attention to the fact that the first deposit to the accumulation account will be made at the end of the first year, and the first distribution will be received at the end of the year 13. So remember, over a 12-year period, there will be deposits into the account. She will start to withdraw $42,000 starting from year 13. So the task here is to find out the amount of accumulation that would be sufficient to finance the distributions. So how much the company should be depositing every year, and how much she should be accumulating by the end of the year 12 so that she can afford to receive these $42,000 withdrawals over a 20-year period. So let's focus on the amount that is needed to finance or to accommodate these $42,000 withdrawals over that 20-year period. And naturally, we could find out the annual contributions that needs to be made by the company to accumulate that sum at the end of the 12th year. So this is the challenge that we have, and we are going to address this issue in the next couple of slides. So a graphical representation is always useful in time value problems. Here I laid out the accumulation period, which starts at time 0. Company makes the first contribution or first deposit at time 1, and the last contribution, which is the 12th deposit or 12th contribution, is made at the end of the year 12. And then her withdrawals are going to start on year 13, and her last withdrawal is going to take place on year 32, or at the end of the year 32. By that time, the account will be drawn down to 0. That means that there is not going to be any money left in the account. So in this case, there are 20 equal withdrawals of $42,000, and during this period, the balance that remains in the account is going to earn 12% interest. So we could solve the amount that is needed at the end of the 12th year by just considering the present value of these 20 withdrawals as of end of year 12. So we could consider this as a present value of annuities. So to solve that, we will use $42,000 as annuities, and we are going to use present value of annuities interest factor, which is 1 plus interest rate to the power n minus 1, divided by 1 plus interest rate to the power n times interest rate. So in this case, interest rate that is earned over the accumulation period is 12%. Number of years for accumulation is 20. And when we plug in the numbers, we get 7.4694 as present value of annuities interest factor, which is 7.4694. When we multiply this with 42, we find out the amount that is needed as of end of year 12. So if she had accumulated $313,717, she would be able to comfortably withdraw $42,000 in each of the years following, starting from year 13 throughout this 20-year period. And once she withdraws the last $42,000, there's not going to be anything left in the account. So $313,717 is the present value of these $42,000 that are going to be withdrawn over this 20-year period. So now that we know $313,717 is needed at the end of the year 12, we can calculate the amount of deposits that the company has to make to accumulate this amount. If we assume that the amount that is going to be deposited is A, this will look like a future value of annuity problem. So there will be 12 A's that is deposited, which is going to accumulate to $313,717. So we can solve that A, because we know that during this period interest rate is 9% and there are 12 periods. So we could just plug in and set up the equation as a future value of annuity problem. So $313,717 will be the future value, and then we have unknown annual contributions, but they are going to be growing by compounding, and the future value of annuity formula is 1 plus interest rate to the power n. In this case, n is 12 minus 1 divided by interest rate, which is 9%. So that factor is 20.14. 313,717 divided by 20.14 is equal to $15,576. This means that if her company annually deposits $15,576 in the next 12 years, she will be able to accumulate enough funds that will allow her to withdraw $42,000 per year over the 20-year period. So this is an interesting problem that involves all of us. You could yourself think about when you're going to retire, how long you expect to live upon retirement, and how much you're going to need per year. And then you could think of how much you need to accumulate until a certain time, or until the day that you would like to retire. And then you could turn around and calculate the amount that you need to save per year. So this is a general retirement problem that we all could do our own calculations. If you have 30 years to retirement, you will have a 30-year accumulation period. If you assume that you're going to live, let's say, 30 more years after retirement, you're going to have 30 years of withdrawal period or distribution period. Any combination of these would help you just to figure out how much you need to save per year during this period. Obviously, the amounts that we calculated here were determined or dependent on certain assumptions, and the primary assumption in this case was that during the accumulation period we would earn 9% interest on our deposits. Under the current circumstances, this is a very optimistic figure. Even risky portfolios do not earn this much of a return. So if we scale back the interest rate, let's say to 4%, the amount of the contributions would have to increase to 20,877 right in here. On a 3% return, the annual contributions will have to increase to $22,105. Obviously, as the interest rates increase, the contributions drop. Unfortunately, in the foreseeable future, returns that we can generate on our investments are going to be probably lower than 7%, probably realistically in the 3-4% range. So if you were Jill Moran, you would have to contribute about $22,000 or $20,000 if you are planning to retire in the next 12 years. That is a pretty sizable amount for savings. And of course, the amount of $42,000 that is going to be withdrawn is a very modest amount, and it would require a very frugal lifestyle. So here is a chart, contributions versus interest rates. The higher the interest rates, lower the contributions, or the lower the interest rates, higher the contributions.